Imagine walking into a doctor's office feeling completely normal. You slept well, you went to work, you ate breakfast, you climbed the stairs. Nothing hurts. Nothing feels unusual. Then the blood test comes back. Your doctor tells you that your blood sugar is higher than normal. Not diabetes, not yet. Pre-diabetes. And suddenly, a strange question appears. How can something be changing inside your body when your body is giving you almost no warning at all? This is the mystery at the center of pre-diabetes, and it is much bigger than most people realize. In the United States alone, the CDC estimates that about 115.2 million adults have pre-diabetes, more than 2 in 5 adults. Even more striking, about 8 in 10 people with pre-diabetes do not know they have it. That means millions of people may be living their normal lives while a measurable change in the way their bodies handle glucose is already underway. There is no dramatic alarm, no obvious moment when the body says, something has changed. Instead, the process can unfold quietly, and that raises a more important question. What exactly is happening before a person ever feels sick? To understand that, we have to go back to something your body does every single day. Every time you eat, carbohydrates and other nutrients are broken down, and glucose becomes one of the major sources of energy available to your cells. But glucose cannot simply wander into every cell whenever it wants. Insulin helps control this process. Think of insulin less like a magic key and more like a signal telling certain cells to respond to glucose and help move it out of the bloodstream. The pancreas produces insulin. Muscle, fat, and liver cells respond to it. When this system works properly, blood glucose stays within a relatively controlled range. But sometimes the cells begin responding less effectively to insulin. This is known as insulin resistance, and according to the National Institute of Diabetes and Digestive and Kidney Diseases, insulin resistance can affect the way muscle, fat, and liver cells respond to insulin. Over time, the pancreas may struggle to produce enough insulin to compensate, and blood glucose can begin to rise. But here is where the story becomes interesting. The body is not passive. It tries to compensate. Imagine a factory whose workers are becoming slightly less responsive to instructions. At first, the manager does not shut the factory down. The manager simply sends more instructions. In a similar way, when the body's cells become less responsive to insulin, the pancreas can produce more insulin in an attempt to keep glucose under control. For a while, that compensation may be enough. And that may be one reason a person can feel completely normal. Their body is working harder behind the scenes to maintain a blood sugar level that still appears acceptable. From the outside, there may be almost nothing to notice. But underneath, the system may be under increasing pressure. Eventually, in some people, the compensation is no longer enough. Blood glucose begins to rise, not necessarily to the level used to diagnose diabetes, but higher than normal. That middle ground is what we call pre-diabetes, and the word itself can be misleading. Pre can sound as if nothing important has happened yet, as if the real problem begins later. But medically, prediabetes is not simply a label for someone who might someday develop diabetes. It is a measurable state in which blood glucose is above the normal range but below the diagnostic threshold for diabetes. And researchers know that this state can persist for years without obvious symptoms. The CDC specifically notes that people can have prediabetes for years without knowing it. That explains something that seems almost paradoxical. A person can have a real metabolic problem without feeling like a sick person. And this is where our investigation takes an unexpected turn. Because perhaps the most important clue is not what people feel. It is what they do not feel. There is no single sensation that reliably announces, "You have prediabetes." The tiredness you had last Tuesday could be poor sleep. The afternoon slump could be stress. Feeling hungry could simply mean you have not eaten. And feeling perfectly energetic does not prove that your blood glucose regulation is perfect. This is why prediabetes is usually discovered through testing rather than symptoms. The blood tells a story that the nervous system may not be telling you yet. Doctors can use several blood tests to identify prediabetes, including A1C, fasting plasma glucose, and a 2-hour oral glucose tolerance test. For example, an A1C between 5.7% and 6.4% falls within the prediabetes range used by U.S. clinical guidance. But even these numbers require context. They are not a simple countdown clock. Not everyone with prediabetes will inevitably develop type 2 diabetes. The trajectory can vary from person to person. Some people progress, some remain in the prediabetes range, and some can return to normal glucose levels. That uncertainty is important because it prevents us from turning prediabetes into a frightening prediction of someone's future. But it also raises another question. If the body can compensate for insulin resistance for so long, what finally causes that balance to begin breaking down? Why can one person's blood sugar remain relatively stable while another person's gradually moves toward diabetes? And what role do the liver, muscles, body fat, genetics, age, sleep, physical activity, and other factors play in that transition? Because the blood test may only be the visible surface of a much larger story. And once we look beneath that number, the mystery becomes even more complicated. The real question is no longer simply, what is prediabetes? It becomes, what was happening inside the body long before the test finally revealed it? That is where the investigation really begins. The blood test may be the moment prediabetes is discovered, but it is not necessarily the moment the story began. By the time glucose crosses into the prediabetes range, the body may already have spent years adapting to changes in insulin sensitivity. And this is where the simple image of high blood sugar starts to break apart. Because blood glucose is only one piece of the puzzle. The liver is involved, muscles are involved, fat tissue is involved, and the pancreas is constantly trying to keep the entire system balanced. Think about the liver for a moment. It does not simply sit quietly in the background. It stores and releases glucose, helping maintain blood sugar between meals. When insulin resistance develops, the liver can become less responsive to insulin signals. In some people, this can contribute to excessive glucose production, even when the body does not actually need more fuel. The muscles matter too. Muscle tissue is one of the body's major sites for glucose use. If muscle cells become less responsive to insulin, glucose may not be handled as efficiently. So the number appearing on a laboratory report can represent the combined result of several systems trying to compensate for one another. That is why researchers increasingly view prediabetes as part of a broader metabolic process rather than simply a problem with sugar. But there is another organ at the center of this story, the pancreas. As insulin resistance increases, the pancreas may respond by producing more insulin. For a period of time, that extra insulin can help keep blood glucose from rising too dramatically. This is an important point because it explains why someone can have significant insulin resistance without immediately developing diabetes. The body has backup systems. It compensates. It adapts. It tries to preserve normal blood glucose. But compensation has limits. When the pancreas can no longer produce enough insulin to overcome the body's increasing resistance, glucose begins to rise more substantially. That transition does not happen at exactly the same speed in everyone, and scientists are still investigating why. Genetics clearly matter, age matters, body composition and fat distribution can matter, physical activity, sleep, diet, certain medications, pregnancy history, and other biological factors can influence risk. But there is no single explanation that accounts for every person with prediabetes. That is one reason simplistic explanations can be misleading. Prediabetes is not simply a story about eating too much sugar. It is a complex interaction between organs, hormones, genetics, environment, and behavior. And sometimes, the most surprising clue comes from people who do not look unhealthy at all. A person can have prediabetes without fitting the stereotype of someone who is visibly overweight. This matters because insulin resistance and diabetes risk are influenced by more than body size alone. Population studies have repeatedly shown that metabolic risk varies across different groups and individuals. Family history can matter, age can matter, ethnicity and genetics can influence risk, and body fat distribution may matter as much as, or sometimes more than, the number on a bathroom scale. This is why looking at someone and deciding whether they look healthy tells us very little about what is happening with their glucose regulation. The blood test sees something the eye cannot. But there is still a major question. If prediabetes can remain silent for years, how dangerous is it really? The answer requires some balance. Prediabetes does increase the risk of developing type 2 diabetes, and type 2 diabetes is associated with serious long-term complications affecting the heart, kidneys, nerves, eyes, and other organs. But prediabetes does not guarantee that these outcomes will happen. That distinction is crucial. A diagnosis of prediabetes is better understood as a warning signal and a measurable risk state, not a prophecy. The CDC estimates that many people with prediabetes are at increased risk of developing type 2 diabetes, heart disease, and stroke. At the same time, progression is not inevitable. cdc.gov. And this is where the story becomes less frightening and more interesting, because the same biology that makes prediabetes difficult to notice also creates an opportunity. The process is often gradual. There can be time between the first metabolic changes and the development of overt diabetes. That means the body is not necessarily moving along a single, irreversible track. Research into diabetes prevention has shown that progression to type 2 diabetes can be reduced in people at high risk through evidence-based interventions. One of the landmark studies was the Diabetes Prevention Program, a large clinical trial that examined whether type 2 diabetes could be prevented or delayed in people with elevated glucose levels. The results changed the way doctors think about prediabetes. The trial found that intensive lifestyle intervention reduced the incidence of diabetes by 58% over about 3 years compared with placebo, while metformin reduced incidence by 31% during that period. NIH.gov. But these findings need to be understood correctly. They do not mean that everyone with prediabetes needs medication. They do not mean lifestyle changes guarantee prevention. And they certainly do not mean people should start or stop treatment on their own. They show something more fundamental. Prediabetes is not necessarily a one-way road. That may be the most important discovery in this entire investigation. The frightening part of prediabetes is that you may not feel it. The hopeful part is that the absence of symptoms does not mean the situation is beyond influence. There is also a deeper lesson here. Modern medicine often teaches us to think in categories: normal, prediabetes, diabetes. But biology does not always work in neat boxes. Insulin sensitivity can change gradually. Glucose levels can move up and down. Different organs can respond differently. And two people with the same A1C can have very different underlying metabolic conditions. That is why researchers continue to study what happens before and during the transition to diabetes. They are asking whether different subtypes of prediabetes exist, whether some people are more likely to progress than others, whether early metabolic changes can be detected before standard glucose tests become abnormal, and whether better prediction could allow doctors to identify risk more precisely. Those questions are still being investigated. What is already clear is that prediabetes deserves neither panic nor dismissal. It is real, it is measurable, it can remain hidden, and it can signal increased future risk. But it is also a moment when the trajectory may still be influenced. So return to the person from the beginning of our story. The person who walked into the doctor's office feeling perfectly healthy. Nothing dramatic happened that morning. There was no sudden collapse, no obvious warning. Just a blood test revealing that the body's glucose system was no longer operating in exactly the same way it once did. That result does not tell us everything. It does not predict the future with certainty, but it gives us information, and information changes the story. The deepest mystery of prediabetes was never why people suddenly become sick. It was how much can change before they feel sick at all. The answer is both unsettling and reassuring. Metabolic changes can develop quietly, sometimes for years, while the body compensates well enough to keep symptoms away. But silent does not mean irreversible, and a warning signal is not the same thing as a final diagnosis. If someone receives a prediabetes result, the right next step is not fear or self-treatment. It is a conversation with a qualified healthcare professional who can interpret the result alongside the person's medical history, risk factors, and other test results. Because the most important thing about prediabetes may not be that it tells you something is wrong. It is that it tells you something is visible now that may have been invisible before. And sometimes in medicine, seeing the problem is the beginning of changing its direction.